Yaskawa. This video shows how to configure an Allen Bradley PLC to communicate with a Yaskawa SigmaLogic servo. Here's a quick preview. First, configure the Ethernet IP instance. Second, import Yaskawa's AOIs to the project. And third, put the MCFG AOI on the top rung. This is the second video in the Quickstart series. The SigmaLogic servo has already been configured and motion has been tested. The SigmaLogic servo axis is connected to a PC and PLC through an Ethernet switch. Now the PLC must be configured in RSLogix to connect over Ethernet IP to the SigmaLogic. For this demonstration, I'm using RSLogix version 20. In the RSLogix software environment, Yaskawa claims expertise only in the functionality of our AOIs and in configuration of the Ethernet IP connection to SigmaLogic. This is not training on RSLogix or application programming. All RSLogix programming and networking questions should be directed to Rockwell. My controller type is the Allen Bradley CompactLogix L32E with an IP address of 192.168.1.10. Both the PLC and SigmaLogic have IP addresses on the same subnet. I have a new project and am not online with the PLC. The first step is to configure the Ethernet IP instance. In the controller organizer, go down to I/O configuration and choose Ethernet. Right-click for New Module and choose Ethernet Module, Generic Ethernet Module, then Create. I will name it SigmaLogic_1, a Yaskawa SigmaLogic Ethernet IP servo. The IP address of the SigmaLogic was configured in LogicWorks as the default 192.168.1.1. Now for the Ethernet IP details specific to SigmaLogic. Under connection parameters, the input assembly instance is 102 and size 64. The output assembly instance is 112 and also size 64. Configuration assembly is set to 1 and 1. Click OK and the module appears in the I/O configuration tree as Ethernet Module SigmaLogic 1. Open its properties and in the Connection tab, be sure that Unicast is checked. Set the requested packet interval, RPI, to 12 because SigmaLogic internally updates its Ethernet IP data every 12 milliseconds. Click OK and Step 1, configuring the Ethernet IP instance, is complete. Step 2 is to import Yaskawa's add-on instructions. The latest AOI can be downloaded from yaskawa.com/SigmaLogic. Then extract the compressed file. In the controller organizer, right-click, Add-on Instruction, and Import. Then navigate to the directory where you extracted the AOI. The most critical and only required AOI is MCFG_Yaskawa. Select and import it. The import configuration displays details about the AOI. Click OK to complete the import. The add-on instruction then appears in the controller organizer tree. Follow the same process to import the remaining Yaskawa AOIs. And Step 2, importing Yaskawa's AOIs, is complete. Step 3 is to use the MCFG_Yaskawa add-on instruction at the top rung of the program. I'll program in the main routine in this example. MCFG is found under the Add-on tab. MCFG_Yaskawa passes data between the PLC and the SigmaLogic servo. This AOI is placed directly on the top rung of the motion program. The input parameters of the AOI must now be defined. Right-click or F1 for help on any AOI describes the input parameter function. The top field of an AOI is a tag for an instance in memory for the AOI to run. Enter tag. I'll name it MCFG_1. Axis in and axis out logically connect MCFG to the Ethernet IP I/O configuration created as SigmaLogic 1. Double-click Axis In and pull down to select SigmaLogic 1, I for inputs, and double-click to select. For Axis Out, double-click and pull down for SigmaLogic_1, O for outputs. Axis is a descriptive logical axis name to be used in all of the other AOI that control this axis. Create a tag Yaskawa servo_1. Notice the data type defaults to Yaskawa_EIP_servo. This data type contains a comprehensive set of information about the axis. Parameter resolution sets a number of recognized decimal places for all positions and speeds. A typical setting is 3 digits of resolution. Feed rate override is a master speed percentage scale factor. For now, we'll set this to 100%. The inward pointing arrow indicates that the remaining data below are feedback to the AOI. Download this to the controller. When everything is working, the HB heartbeat output flashes on and off in the MCFG block. The heartbeat confirms communication between the PLC and SigmaLogic. Any motion of the axis is reflected in position and speed feedback. This connection process can be repeated for each additional SigmaLogic axis. With the connection established, motion programming can begin. Please look for our e-learning videos showing basic motion control, homing, and using the sequence table with SigmaLogic. Thanks for watching this video, and remember yaskawa.com/SigmaLogic for videos, documents, software, firmware, AOIs, and more.